So we're up to section 9.5, confidence intervals for the population proportion. So up until this point in chapter 9, we were constructing a confidence interval to estimate the population mean, which is mu. But remember, that's not the only parameter that we might want to study. We might be interested in proportions. Just like in chapter 8, we started talking about sampling distribution of the proportion. So another parameter that we're going to estimate using confidence intervals is going to be the population proportion P. Before we do this, I just want to do a quick reminder of sampling distributions of the proportion. So chapter 8. So just remember sampling distribution of the proportion P hat. So remember the characteristic. So P hat is approximately normal if n times P is greater than 10 and n times 1 minus P is greater than 10. So remember that central limit theorem for sample proportions. And then we also know that mu sub P hat, the mean of all the sample means, is equal to P. And the standard error of the sampling distribution of the proportion, or the standard error, right, sigma sub P hat, that was equal to the square root of P times 1 minus P over N. So this should be very familiar. We did this in the previous chapter. So I'm just recapping what we learned about P hat in chapter 8. But realistically, in real life, we don't know what P is, right? We're trying to estimate it. So now in this chapter, in chapter 9, we're going to construct a confidence interval to estimate the population proportion, and we're going to use P hat as a point estimate. So we don't know P. So we're going to use P hat as an estimate. So we're going to have to calculate S sub P hat, which is going to be the square root of P hat times 1 minus P hat over N, because we're using P hat in place of P because we don't know what P is. It's unknown. So this estimate, the standard error, is called S sub P hat when we're going to use P hat as an estimate of P. So that's why you're going to see this in the formula for the confidence interval for the population proportion. So let me go back to the notes. So under the assumption that the sampling distribution of the population proportion P is approximately normal, P hat serves as a point estimate of the population proportion, and S sub P hat serves as an estimate of the standard error, just like I showed you on the whiteboard. And the reasoning that was developed in constructing confidence intervals for the population means that we did previously in the last couple of videos to construct these confidence intervals for the population proportion is going to follow the same thinking. So you'll see that the formula for the confidence intervals now to estimate P when we're assuming n times P and n times 1 minus P is greater than 10, so we're going to use a normal distribution. We're going to use a very similar formula. We're going to take the point estimate, which now is P hat, and we're going to subtract the z-score, and we're going to multiply by the standard error, which is this guy that I pointed out on the whiteboard, the square root of P hat times 1 minus P hat over N. And the z-score is already done for you because whenever we're talking a 90% confidence interval, the z-score or the area under the normal curve is always going to correspond to a z-score of 1.65. Whenever we're going to construct a 95% confidence interval for the proportion, the z-score we're going to use is 1.96. And whenever we construct a 99% confidence interval for P, we're going to use a z-score of 2.58. So the margin of error is E, which is going to be the z-score times the standard error, just like we did for means. except now we're going to take, instead of a t-score, we're going to use the z-score times the standard error, right, for proportions. So in each one of these, this is our standard error. So this is E, right? That's my standard error. These guys right here are going to be my standard error. So this, the margin of error, I'm sorry. So the margin of error is still going to be 1/2 the width of the confidence interval. So let's do an example. So example 6 says, a university dean is interested in determining the proportion of students who receive some sort of financial aid. Rather than examine the records for all students, the dean randomly selects 200 students and finds that 118 of them are receiving financial aid. So A says, let's use a 90% confidence interval to estimate the true proportion of students on financial aid. So now we're going to construct a confidence interval, but not to estimate the mean like we were doing in the previous examples. Now we want to estimate the population proportion of students that have financial aid. So it's a different parameter altogether. So I have to use this formula. We're going to use this formula to calculate the confidence interval for proportions. So I'm going to write down the formula here so we have it in front of us. So we're going to take p hat, my point estimate. We're going to minus the z-score times the square root of p hat times 1 minus p hat over n to p hat now plus that margin of error. So times the z-score times the standard error. So the square root of p hat times 1 minus p hat over n. And since we want to construct a 90% confidence interval, if we look at our formula for a 90% confidence interval, the z-score that we're going to use is 1.65. So I'll do A down here. So we have to take p hat minus the z-score times the standard error. And then we're going to take p hat and we're going to add the z-score times the standard error. So we need p hat, we need z, which we already said is going to be 1.65, and we need n. And once we have those values, we could plug in. So we know that n is 200, right? Because we took a sample of 200 students. So it says right here, n is 200. And X of them are receiving financial aid, so 118 of them. So X is 118. So although p hat wasn't given to us directly, we can calculate it, right? Because p hat, remember, p hat is equal to X over n. We learned that in chapter 8. So p hat in this case is going to be X, which is 118, over n, which is 200. So what is that proportion of students from the sample that get financial aid? What's 118 over 200? It's 0.59. So that's p hat, n is 200, and we said my z-score for a 90% confidence interval is 1.65. So we could plug in. So we're going to take p hat, which is 0.59. I'm going to minus 1.65 times the square root of p hat, which is 0.59 times 1 minus 0.59 over n, which is 200. That's the lower bound on my confidence interval. Now we have to take the point estimate, 0.59, and we're going to add the margin of error. So we're going to add 1.65 times the square root of 0.59 times 1 minus 0.59 over 200. And then this we could plug into the calculator. So we have 0.59 minus 1.65, and then we're going to take the square root 0.59 times 1 minus 0.59 over 200. I just wanted to write that down before I go over to my calculator. So let me share my calculator screen. So we're going to take 0.59. We're going to subtract the z-score 1.65 times the square root of 0.59 times 1 minus 0.59 divided by 200. And I'm going to go 4 places. So we get 0.5326. And now that's going to go to the upper bound on the confidence interval, which we have to calculate. Remember what I said. We don't have to type this whole thing again. Press second and enter, and then just arrow back to that subtraction and just make it a plus. Okay, so make that subtraction a plus at the beginning. And now we're going to get the upper bound of 0.6474 if we go 4 places. When you do the homework, the computer will tell you how to round. So my confidence interval is from 0.5326 to 0.6474. And what that represents is the range on the proportion of students who receive some sort of financial aid that we're 90% confident is going to include the true population proportion of students that get financial aid. And we'll write down the interpretation for Part D. So Part B says, what is the width of the confidence interval? So remember, to get the width, we just take the larger value minus the smaller value, and that's going to give us the width. So we're going to take 0.6474, and we're going to subtract 0.5326. And we're going to get 0.1148 for the width of the confidence interval. And then C, the margin of error, is just the width divided by 2. So we're going to take the 0.1148 and then divide it by 2. And we get 0.0574. And then D, write a statement to interpret this confidence interval. Very similar to when we were doing the interpretation for means. So we say, we are 90% confident, because that was my confidence level, right? We are 90% confident that, what are we trying to estimate? It's the proportion of students on financial aid. So we are 90% confident that the proportion of students on financial aid is between 0.5326 and 0.6474. So we're estimating the proportion of students that are on financial aid to be between about 53.26% and 64.74%. You can interpret it that way also, or you could just leave it in decimal form. So this is how we create a confidence interval to estimate P, the population proportion. But just like we did with the means, there's a function in the calculator that we could do that is gonna, plug into this formula for us, and it's gonna be much quicker. So going forward, we'll use the calculator, and I'll share that in the next video, how to use the calculator.